Good. It's 5 o'clock, so I think we can slowly start, at least welcoming the people who are joining us today. So I wish good day to all, whether you are starting your business day, if you are in US, for example, or you are closing your business day like you are in Europe. I'm glad to be today with you and with Tino. It's a long time, Tino, we are not together. Even it's almost more than 1 year we are not together in person.
Physically, yeah.
It's but hopefully it will change. So I think it is 5 o'clock. We can start. Today we are here in one of the many webinars arranged by GMI.
Oh, that's me. Sorry. Okay.
No problem. No problem. Anyway, I was about to move the cursor, the page, but now it looks like.
Yeah, you're moving. Here we are.
Okay. So today we are here with Tino Van de Capelle, one of the deep experts in functional safety. It's our speaker today. It's our partner, business partner with GMI. It's our trainer for our functional safety training program. We will talk about later. Many of you have already had the opportunity to be trained by Tino and to get the functional safety engineer qualification. GMI is sponsoring this training together with TUV. And yeah, my recommendation it is to have a look to our website where we have our training schedule. Very soon it will be updated with 2022, if not yet done. It is a matter of day. And so please have a look and check when it could be the opportunity to be trained by Tino. Today we have, we will get from Tino, thanks Tino for sharing your knowledge, a piece of knowledge. Today we touch the subject in the functional safety, we touch the subject of safety requirement specification. Before to do that, yeah, let me just introduce very shortly the company. GMI is an Italian manufacturer of field interface, specifically knowledgeable of functional safety and intrinsic safety matter. You can find our equipment in many of the packages in the automation of oil and gas, petrochemical, pharmaceutical, and mining and food industries. GMI has a lot of experience in this matter, and we are an Italian manufacturer with presence worldwide. We are present worldwide. Yeah, so we have several offices, and I can tell you, even in this period of COVID, even we are getting out luckily, and we will be soon back, hopefully, to the normal situation. We are growing, and these numbers are subjected to be increased in the next week and month. So, as said, sorry, safety means for GMI protection of. Sorry, something is going wrong in the. Okay. Is protection of human life, of environment, as well as asset of companies. So for us, the quality in our production is very important. That's why we have state-of-the-art technology. We have full testing, and we are caring a lot about the quality of our product. Of course, that's why. To reach this level of quality, we have all necessary certificates, as well being a company present worldwide. We have to ensure to our customer that our product are fulfilling all requirements of and the destination. That means all certificates in order to be able to be delivered, to be installed in all countries of world. So you have here just a short list of a logo representing the various certificates which allows you to use the product worldwide. Here, this is just a short one page representing the portfolio of GMI. So we are starting from, again, something's wrong. We have, okay, here we are. The bullets representing our portfolio. So we are talking about intrinsic safe barrier, safety relays, isolator, power supply systems, as well as multiplexer, hard multiplexer, and termination board in order to customize the application to the several control system and safety system available in the market. We have surge protector as well as loop indicator. And of course, even if it is not a product, we have our department in functional safety. Today we have Tino with us, our functional safety director, as well as we have a department for intrinsic safety, and through this department, we share our knowledge with seminar, with trainings, and we share our expertise with our customer through webinar, through trainings. We will talk later about the program that Tino holds together with GMI. What else? This is, if the page will support me, here it is. This is just a short list of a typical customer for GMI. And okay, I want to, and finally, yeah, today there is something wrong with the presentation. Anyway, let me just, before to introduce and to leave the speech to Tino, let me say that you have the chance to see this webinar over YouTube. We have a YouTube page where you can see this webinar as well all other webinars that we are organizing over the time in different subjects. As said, we cover functional safety, we cover intrinsic safety, we have dedicated webinar on specific application of some of our product like safety relays. So if you are interested, you can either go to our webpage and to see the schedule of our webinar, or you can have always a look to our previous webinar. Another point I would like to tell, you have the possibility to raise question. Once I give the speech to Tino, I will be the hearer and I will monitor the presentation. And if you have any question, you just type the question in a question and answer space dedicated, and I will interrupt Tino in case of necessity. At the end of the presentation, we will have also a question and answer section. We collected some questions during the registration process as well. We have questions which were coming from previous webinar, which we believe it is of interest to share. So at the end of the presentation, we will have also that section. Total duration will be about approximately 1 hour. And now let me give very last information. You will receive an email with the PDF file of this presentation. And later on, if you believe there is something that you would like to clarify deeper, we are available for you. So, Tino, I leave the speech to you now.
Okay, thank you. Thank you, Mauro. Can you just remove the control?
Let me try.
Yeah, that's it. I think you go. Very good. So welcome everyone. As Mauro was saying, this is a webinar just to create some awareness of some of the topics of the functional safety standard called the IEC 61511. Today's webinar is quite a generic, I would almost say quite a simple topic. It's called the Safety Requirement Specification. And I personally believe, because many people think it is simple, that is also why that people do not manage to even, let's say, formulate or define in details what exactly a safety loop is supposed to be doing, or is supposed to be achieving a safe state, etc. So some of the topics we're gonna address will be related to this phase number 3 over here. That's the first picture that you see, the life cycle. For people who have never followed a training course, who have never heard about functional safety standard called the IEC 61511, in a nutshell, the 61511 was actually the first release, edition 1, came out 2003/2004, whereas the second edition, that means the revised edition, came out in 2016/2017, is a dedicated standard to build a quality safety instrumented system for the use in the process application. Under process application, we are mainly focusing, of course, on oil and gas, chemical, petrochemical. Additional by edition 2 is also now we have pharmaceutical, and we also have food and beverage. A life cycle, basically, in principle, is a working method step per step. So it's a systematic approach to tell the engineers how to start, how to document, how to prove they have done the work correctly, how to check their quality, how to verify that the functions will work as they were based or as they were defined on paper. And today's session, as we already mentioned, will be here highlighted is box number 3. We call this phase number 3. That means in some of the previous webinars, we may have handled the hazard and risk assessment. And the second bullet is here called the LOPA, or the layer of protection analysis. So those 2 phases are done. We will not talk about this in this right moment in this webinar. We are focusing on, now we want to define what additional safety instrumented function do we have to create, do we have to define, enable for us to achieve the necessary risk reduction. So again, we're going to define what type of SIF do we want to build, and what are the functionalities that that system has to fulfill in order to achieve our functional safety. The first 3 phases of the life cycle, as I just mentioned already, phase number 1 requires that you will identify the hazard, you will analyze the hazard. That means you make some analysis to find the answers, such as you want to know what are the severities of the consequence of the hazard when the hazard occurs. And the second answer you try to find in the analysis is what is the frequency that such a hazard can occur. So that's all done in phase number 1. In phase number 2, we already mentioned this, we call this LOPA. LOPA stands for the layer of protection analysis. Layers on top of each other. Every layer will have a certain functionalities. It's quite important that edition 2 will highlight that those layers needs to be 100% totally independent and separate from each other. And you will also see that if we do have some specialists attending this webinar, it's always the question is, what and how much credit do you give to your non-SIS layers or your non-safety layer? How much risk reduction credit are you allowed to give? Again, edition 2 with LOPA has some very specific, let's say, rules and guidance or limitation, which many people are not even aware of yet. But that's the new edition 2 since 2016, 2017. If some people from the North America region are joining us, you call this the ISA 61511, which is your edition September 2018. That means you back in North America waited for 2 years to adopt the standard, the IEC 61511. But today's session, as already mentioned, will be the phase 3. When the tolerable risk, that means when you get from your end user or you are coming from the corporate management or whatever, they will give you the allowance on what type of consequences, what type of frequencies are we, let's say, accepting in our industry or in our culture or in our company. And based on that criteria, we call this a tolerable risk. We need to figure out the hazard that we identified with the consequences and the frequency, how much likely it is that this frequency will happen. Do we have to reduce this? Yes or no? Assume that we have to reduce the frequency of the hazard occurring. That means we're going to try to come up with a kind of a safety loop. And I'm pretty sure that most of you have heard about safety loops such as SIL 1, SIL 2, or SIL 3. That only means it's a performance band, how much risk reduction such a performance band can fulfill in your installation. I got the first question, the first poll question that Mauro will launch, and I will read the question in the meantime. I would like to talk about the ownership of such a document of a safety requirement specification before we start the webinar. And you have the potential here to answer the following options. Do you think the ownership of the safety requirement specification lays with the safety consultant / or the safety company? B, it is the engineering contractor, call it the EPC contractors, who are responsible as an ownership for the SRS, for the quality. Or it is the SIS integration team who is responsible as an ownership for the SRS. Or it is the operating company or the end user who has the ownership. Or you give it to the operator and maintenance teams, the people who are responsible to maintain and operate the SIS on site. Or you think it is the MAC contractors or the main automation contractors, or G, it's all of the above. Which one do you figure out has the ownership of the safety requirement specification?
Okay, we are getting good response so far. So let's wait anyway some minutes again, some few seconds again. We give the chance to all to answer. So I see quite a diversified answering. So you will comment later on, Tino. Mm-hmm. Good. Let's give it another few seconds and then we stop it and we share the result. I think we can stop it here.
Okay.
Shall I share it?
Yes, please.
Okay. Here it is.
So the ownership. Actually, the answers is quite mixed, as you can see, from the entire group who has joined us today. We have like a broader mix of, well, some of you, 15% thinks it's a safety consultant. The other ones are thinking it's the engineering contractor. I got the SIS integration team. I got the end user, I got the SIS. There's none of you are answering the MAC. Well, the only correct answer, according to my, let's say, understanding and also the ownership, and I will also tell you why I'm giving you that comment. The ownership of the safety requirement specification, it means a document that is describing how we will achieve the safety on site, lays always with the operating company / the end user. For the following reason, the end user / operating company management, the plant management, they are responsible to maintain safety on their site. Therefore, the document describing how safety will be achieved lays always with the end user and not specific. And I know that it's a common, let's say, mistake of understanding that some people point the finger to the safety consultant or to the engineering contractors, or even, I would not say the SIS integration team. I have not often seen that, but we see very often when you hire a safety consultant or when you hire an engineering contractor, that you blame him for something which was not correctly defined. Bottom line is, when an end user / operating company is hiring X company, well, they need to hire a competent company who can prove competency for the activities which they are responsible / accountable for. That means that when the end user / operating company is hiring a specialist to define the safety requirement specification, that still means that the safety requirement specification ownership lays not with the EPC who is creating that document, it's still remaining with the end user. I will stop sharing this, Mauro, and I will continue.
Yes, please.
Okay, so the objective of such a document is clearly to have a complete safety instrumented system requirements for building your, let's say, architecture, for understanding how the loops will have to function, including also the topics covered by your logic solver. That is why next to our safety requirement specification, our SRS, we also need an application program safety requirement specification. That application program SRS has been changed by the edition 2 in terms of requirements. In a nutshell, or in short, what I can mention is that your application program safety requirement logic needs to be specified regardless what brand of safety logic solver you will implement it in. That means it needs to be very clearly described exactly how the programmer later on will have to translate the giving document into a working program. The SRS may be a single document, but in reality, it's almost always multiple documents. The more documents you will have, the more will it be a challenge, call it a mess in the future, enabled to maintain a clear revision between all the documents. Of course, an ultimate, let's say, document would be everything in one, but that's nearly impossible or impractical to maintain and also to use. But that is a standard describing that the safety requirement specification needs to be, let's say, practical for the people who needs to use it. The SRS shall be written to aid comprehension and interpretation for those using this information during the life cycle. Now, the standard is very clearly and very strongly telling you the following sentence, and I actually copied the sentence, which is not often happening in some of the webinars. I'm relating my story here to part 1 of the standard. Part 1 means that's the normative section. That's in contradiction to part 2 and part 3, which is the informative section. For us as safety engineers, everything which is in the normative section is no discussion possible. It is what it is written in the standard. And if the standard is saying you shall do it, well, then there is no debate possible. You shall be able to prove evidence if you want to comply to the good engineering guideline called the IC 61511. So it states the following sentence. It describes 29 specific requirements per safety instrumented function that shall be sufficient to design the SIF and shall include a description of the intent and the approach applied during the development of the SIS safety requirements. And I put here something in blue. The sentence is finishing off as applicable. You can already imagine if you are a creative engineer, you can say, well, I want to list my 29 items and I want to answer not applicable. And mainly the engineers will abbreviate this in N.A. not applicable, because it's very easy for them to cut, copy, paste. I can tell you that when we are doing an assessment on site and some engineers or some end users are giving us a safety requirement specification and we see multiple not applicable, we may be very critical to understand why you believe it's not necessary to describe this. Because you have to figure out the following. If someone opens this document, someone who has zero know-how of, let's say, what went on before the document was released, needs to be able to clearly understand what needs to be built in your, let's say, factory or in your production unit, enabled to achieve a safety function that is working to achieve your safe state. We will, of course, not cover here, as Mauro is saying, we only are using a maximum 1 hour, and I'm typically keeping my speech between 30 to 40 minutes. I'm always overrun, but I will try to do my best today. But we will not be able to handle all the 29. What I have done is here, I give you a link to the book. This is a book which has been available through GMI, which is the company that you are listening to the webinar with. They are sponsoring this webinar. So they also have about 50,000 plus. It's even more in the meantime, but it used to be around 50,000 books, which has been supplied worldwide. If you are interested, I'm sure that Mauro will be happy to get your details and we can arrange something for you. But in that book, which is the 4th edition, in chapter 8, I have been including an exact one safety instrumented function, including all those 29 different items. That means that I have been describing the definitions from a standard, bullet per bullet, starting on 8.2.2.1, all the way down to bullet 29, which is starting here, bullet 21 starts on page 223. And it goes all the way down to page 249, which is here the reference giving from the book from GMI. What is the minimum? Well, let's talk about the simple things. What does your safety function has to do? In other words, the minimum requirements we always look for is, what do we try to measure? Is it, for instance, your level meaning when your level is meeting a certain trip point, maybe you have to open or close a valve or start or stop the pump or the motor. That means that the second bullet is what logic we need to try to figure out between when we measure the condition we like to measure. What is the final output? What is the actuating function that we want to start? Typically, a safety system is working through a digital output. It may go through one of the interposing relays, and make sure that you choose also a safety integrity relay and not use a normal interposing relay. Otherwise, you may lose your complete integrity of your safety loop. But assume that you use one of the safety relays from GMI, and you are connecting this to the load of your solenoid to open or close a solenoid to maybe cut or supply the instrument air that goes to a shutdown valve. Well, that's a classical safety loop. So safety loops are typically controlled by digital output. It's on, off, open, close, start, stop. That's all we do in safety. But we need to know exactly how fast do we have to achieve. From the moment we measure to the moment we achieve our safe state, we have some definition for that. We will call that the response time. Your safety integrity function response time between your measurement and achieving your final output, your safe state, that time we try to figure out that this time needs to be maximum 50% of the allowable process safety time. So some rule of thumb we take the process safety time divided by 2. We will seek in the industry some installation instrumentation that can fulfill that timing. And the last one is, what is the performance that this safety loop needs to have? Do you have to have a risk reduction factor equal to a certain number, minimum or more? Those are the kind of information minimum that we would like to see for every single safety function. Besides this, what else can we discuss? For instance, every single safety loop will be linked to one unique hazard or to one unique hazardous event only. That means that every single safety loop in your industry needs to be dedicated in the description. What hazard does that loop try to prevent me from? Bypass requirements. I'm pretty sure that most of you have seen bypasses. Well, bypasses is, it's always necessary in the industry once in a while to activate a bypass. The whole question will be, can you guarantee your safe state during the time from your bypass? That is number one question. Number two question, how long do you allow this bypass to be on? Because you're starting to potentially degrade your safety availability by initiating a bypass. So what addition 2 is now requiring, you need to prove evidence that you first will foresee compensating measures before you are allowed to activate a bypass. Third bullet, proof test implementation. As an example, in the book also from GMI, which is in chapter 8, I've given you a proof test implementation story of 5 pages. One of which is, it's a device from GMI. And in the safety manual from a device which is compliant to the 61508, the vendor shall describe exactly how the end user will have to prove that the unit is still fulfilling the specification by definition it was defined for. In other words, you will have to be told by the manufacturer specialist, how can you claim proof test coverage for a given unit or for a given system or a subsystem. The proof test interval will all depend on what risk reduction factor do you try to achieve. As you may know or may remember, some of you, will be that your safety instrumented function needs to prove how good, what is the performance that you can achieve with that. In other words, you will have to define how long you can wait to do your proof test. Once you do your proof test, you will have to prove how good you can do it. And the third one is now new by addition 2 is you also have to prove now how consistent that those proof test intervals / coverage factors can be proven over a period of time. The fourth bullet, assumed sources of demand. What type of potential sources can actually trigger my safety loop to go into a shutdown function? Mode of operations. We have the mode of operations. We will have a low demand, a high demand, and a continuous mode, which are 3 different modes described in the standard. I will not go too much in detail other than low demand will be when your safety instrumented function is triggered maximum once per year to go to shutdown. That's a low demand. More than once per year, That's a high demand, continuous, as the word is saying. When you are using continuous output to trigger, means an analog output to trigger your safety loop to maintain safety in your production unit. How can you start up? How can you shut down? And how can you reset your safety loops? What many people will not know or may not have seen in the standard yet, every single shutdown push button, emergency shutdown push button, shall be wired independent from your logic solver. That means that when you take your shutdown push buttons in your logic solver, make sure that your SRS will clearly identify how to do that. If your SRS doesn't mention it, you're not allowed to use the logic solver for shutdown of a push button. Reset. Every single safety loop that goes into shutdown needs to have a manual reset before it will reactivate, providing the condition in the field is back to normal. I mean, those are some of the generic ones that I'm very briefly mentioning here. Of course, there are many more. If you would like to see more, I would recommend either to go into the book from GMI or maybe to follow one of the training courses that we have online. What are some of the challenges? Some of the addition to challenges that regardless of the years experience that I have been talking to some people with, it's a challenge to understand what the new edition 2 from the 61508 2010 April, followed by the 2016 edition 2 of the 61511, what distinction, what difference do they make now between the mean time to restoration, which is the bottom, the second bullet called the MTTR, and the MTTR used to be called mean time to repair. And if you have some specialists listening into this webinar, you may, if you want to go back into your calculation prediction of availability of your safety loop, means your SIL verification calculation, you may quickly see that some of the calculation may focusing on an MTTR of 8 hours, 24, 72, or 96 hours. There are even some commercial calculation packages that they limit you to fill in maximum 300 plus hours. And the reason for that is very simple. If I would put an MTTR in there of like 5,000 or 10,000 hours, my SIL may be gone. So if you look on the MTTR now, which is here the bottom graphic, which I have made, the A time is a time that you will need before you will find out that your SIF is not working. When do you know your valve is stuck open? Well, very simply speaking, when you try to move the valve. If you never move the valve, you never know the valve is stuck open. So what is now the main problem we have in the field is that all the proof test intervals with end users, they classically start from 1 year, 2 years, 3 years, 4 years, 5 years, and even though customers, they go for 8 years. That means in theory, you will have to wait for all these hours, all these years, before you will find out that your final element or maybe your safety loop is not working as per design. That's your A time. Once you know it has failed, do you have it in spare? Yes or no? Some of you may have some critical spares. Some of you may have a service contract. That means that the service provider will have to be on site inside 24 hours or whatever. Some of you may have nothing, not a service contract, not spare parts. You have to order it. That means shipment, custom clearance can take days, weeks, hours, months, whatever. All of that time is your B time because you have to prepare yourself. You have to have the spare part available. The C time will be your effective time to repair. And the D time will be taking the component or device back into service. From the time you knew it fell to the time it works again, that is called the mean repair time or the MRT. But what is the longest time? Mainly in the field, it's always the A time, which is the time which is very close to your proof test interval. The last slide on this, on the SRS that I want to give to you is, I mentioned this already, the target will be to provide information to the person who will program the safety PLC that he or she knows exactly what logic needs to be programmed between the inputs to the outputs. That sounds maybe a very, let's say, simple explanation. But if you think about it, and I give you a clear example, my history is I've been working for many of those safety PLC vendors in my career. And I can tell you now that if you take a 2 out of 3 function block from vendor A, you take a 2 out of 3 function block from vendor B, what do they have in common? They both call it 2 out of 3. But the internal, call it kitchen, the internal structure, functionality, the way they are built is different. That means that the information giving to those type of people, you as an end user responsible to maintain safety on site, you need to exactly tell on paper what information needs to be programmed. And I fully agree that that paper is mostly made by engineering contractors or maybe safety consultants, etc. Doesn't matter who makes it. You have to use competent people to define it. You have to use competent people to program it. And then you have to have competent people to prove it is working as per requirements, etc., etc. It means that on top of this application program, what is now new by the edition 2 of the 6.15.11, we have so-called the 4I principle for the verification. Means that the original author that is actually writing the program cannot be the same person that actually will verify that the program was written correctly. Because now we want to see a second independent person from the author that is competent, needs to prove evidence how he or she has checked the program that the other person, the author then, has been writing. Those are all kind of items that you will find down here in this clause 12, which is called the application programming of your 6.15.11. Right, we have the second poll of this webinar, Mauro.
Yes, I will share, launch now the poll. Okay.
I was expecting you would talk longer because I was just drinking some water. Anyway.
Ah, okay, sorry, I didn't see you because the poll was covering your face, so sorry.
No problem. So,
okay.
Would you consider now the safety requirement specification as, and those are some typical questions that we see people in training courses struggling with. Would you consider the SRS as a design specification document? Would you consider an SRS on the long run for the end user operating company as an operational instruction document, as well as, or as a maintenance instruction document? Would you consider the SRS as a SIL verification reference document? Would you consider it as an as-built document? Or would you consider it as a all of the above? That means it could be serving for everything. What do you think is here your preference or your opinion on the selection of this poll question?
Okay, we are almost reaching the 100%. So we leave again some few seconds before to close the poll and to comment the result.
It's a single choice answer, so you cannot click A and C. You have to click either one of them. Okay, Mauro,
okay,
we are...
Yeah, I stop the poll.
Okay.
And share the result so you that...
Okay, we have 22% saying that's a design specification document. Well, as the name is called safety requirement specification, you would consider it as a design specification document, which is true. That's not wrong, it is true. As well as you can use that document to operate your safety loop, because if you are responsible for operation of your system, I mean, where else will you find the information exactly how the system will have to be started, stopped, shut down, reset, etc. That means you can find this also there in this document. As well as you can also use it to do some maintenance. If someone asks me, can you go and do a loop check on this loop? I mean, where can I find all the information? Well, I can start with the safety requirement specification SIF description. And in that SIF description, I will see exactly how the loop is supposed to work. D, I can also use a document to find out what is here now the purpose of this loop. How can I actually see what is, for instance, my architecture of my loop? What is, for instance, the requirements for my safety integrity versus my systematic capability of my equipment? I can find this also here in my safety requirement detail specification. And of course, it goes without saying that the SRS will need to be maintained for a duration of the life cycle of your system. That's why the SRS becomes, at the long run, your as-built document. So the only correct answer that I would consider here is like 44% of this group has been figuring it out. It's all of the above. So you can use the SRS for all of those activities which I just have been describing. All right, Mauro, I will stop sharing this and I will click here on the next slide. As we already said, you can send us an email. We will show you the emails later on. It will also be provided, as Mauro was mentioning before. The slides will be captured now into a PDF and will be sent to you by email, as well as I think there is a kind of a certification of attendance of this webinars that some people may find interesting. The book itself, make sure that you get the 4th edition, because there are also different older editions, edition 1, 2, 3. I think edition 1 and 2 do not have the safety requirement specification in there, only from edition 3 and 4. But in 4, which is the latest status of the book edition, there you will find in chapter 8, you will find some of the items which I just discussed. We also have a GMI Academy, which has actually been relaunched again. So you can reserve your seat also on there, which is very similar to what we are providing now in parallel on this YouTube channel that Mauro was mentioning before. If you go to YouTube and you look for GMI webinars, I'm sure that you will find the link. If not, you can ask also by email and we can help you to find. But that should be easy to allocate on YouTube, all the webinars. Every webinar, regardless if you have done like this one now today, the SRS has been done last year in October, and you can compare those because sometimes my story is changing. It's all depending on what is coming up in my, let's say, in my speech when I'm looking at the slides. We can support you also as GMI, as Mauro was saying, they're working together with myself, and I'm the approved course provider by TUV Rijnland for several courses. Those courses here, those 3 bullets, the main course or the first bullet is the Functional Safety Engineer SIS Competency Review Program. I was one of the original founders back in 2004, 2005. From the 4 original trainers, I am the only remaining trainer until I will retire or until I will quit. It's one of the 2. I hope I will not like my other colleague, because we lost 3 colleagues already. One actually quit, the other one has retired, but unfortunately, the 3rd one of the 4 has passed away a couple of years ago. But in the meantime, we have, of course, a number of trainers worldwide. I'm still active with the help here of GMI. I've been training, last week was my last training face-to-face. So we also provide this training virtual, like in a couple of weeks, I'm doing one for the North America region through GMI America support, but they are organizing it. Second bullet is the fundamentals of cybersecurity. That will not be myself giving, it will be one of my colleagues who is the cybersecurity specialist. He came from a large multinational chemical industry background, where he was a cybersecurity specialist for over 25 years. So he has a lot of war stories to talk to you and to explain you why you should take cybersecurity on your industrial automation control systems a bit more serious, because we see more and more problems and attacks, and let's say either ransomware or also some viruses that are sneaking up into the process industry, which is scary, because we are, as safety specialists, we are very afraid that our safety system layer would actually be infected and not being able to shut down the plant. That is what we are really scared of. That's why we have the 3rd bullet, very important. It's required by the 6.15.11 edition 2 that you shall carry out a security risk assessment, where we have a dedicated training course for that. And both the fundamentals and the cybersecurity are also part of the TUV Rijnland competency review training program that we can help you with. We also do customized in-house trainings. We have done several of them this year. Some of them were virtual. I've done one in-house with an end user here in Europe. And of course, we have more webinars to follow. We also provide you with service. That means on all the lifecycle activities, both the lifecycle for safety, which is called the 6.15.11, or the lifecycle support for the OT security, which is called the IEC 62443. We can provide you with some of those services. And that's it. I will stop here my screen, stop sharing, and I give back the word to Mauro, and we will run the Q&A by memory.
Yes, we run the Q&A. It's my now duty to run the Q&A. And can you please confirm whether you can see the Q&A?
Yes.
Okay, very good.
Q&A stopping.
Yeah. So thank you, Tino. As mentioned before, we have now a section where we collected some frequently asked questions. So we can go through. We have today 4 questions. And so let me try. Okay, here. Can you see
the question, Mauro?
Oh,
I will read the question, okay?
please.
So I had this question, and to be honest, I was a bit, well, I read the question several times because it's not always clear what people are trying to ask. And when I was starting to read this question, I was wondering if I really understood it. So I will give you my answer, my 2 potential answers, because you have 2 ways to look at this. The question was, if one normally closed relay contact is installed in the loop, but no action is required by the relay to activate the trip. And it's the word to activate the trip that was actually starting to confuse me. But let's first finish the question. Normally closed relay contact is for reset function after the trip. In this case, normally closed relay will not be considered in the SIF question mark. Mauro, next page, please. So when I was starting to read this, I was trying to understand what this engineer was asking me, and he's asking clearly it's a normally contact, which is somewhere an integral part of the safety loop, and a normally close contact is only used to reset. So in other words, you can assume that if someone pushed the button or someone activated that relay, and a normally close contact is a normal condition is open, right? That means when you deactivate the relay, the normally close contact will close, but when you actually release it, it will go open again. And I'm thinking here 2 potential answers. When using a de-energized to trip, let me first explain what is de-energized to trip. That is all the majority of all the safety loops. You take the energy away of your loop, enable for your final element to go to a safe position. We call this the normally de-energized or the fail-safe principles. If it fails, it is supposed to go to a normal safe state. Well, when you're using a de-energized to trip, then the normally closed contact to open the circuit load could be considered as not an integral part of the safety integrity, since a single failure of that normally contact would not necessarily make your loop unsafe. Thinking about this, if your normally contact would fail and would go open without you wanting to give a reset, well, then the loop would actually trip. So that is why I was starting to think, like, I don't think the engineer would ask such a, let's say, simple question. It may be just the opposite. So the other one, because he used the word activate in the question that I was starting to think of, maybe the engineer, he wants to talk about using a safety loop to energize to activate the safety loop. That means in a normal condition, there is no load, there is no power on the loop. Those are the classical line monitoring modules or the line monitoring safety relays, like GMI has some of them. That means in normal condition, there is no load that is going into the field. But the moment you need to activate, the moment you need to start your deluge system, as an example, you will power up the solenoid. That means that we are afraid that the moment you want to activate to achieve your safety function, the safety function would not be available. In that case, of course, then the normally close contact would be based on the integral part of energized functionality. But again, I'm not really 100% sure what the question really was the intention to ask, because both, even if I read this answer here loud now and I'm looking at it, even now I'm still confused. I'm not sure that I understood the question correctly. So apologize if it is not answered correctly. Maybe if that one person is online, he can identify himself and come on the Q&A and he can ask the question in a proper way, because I would like to understand what this question was all about. Yes, Mauro, next one. This is one coming from the previous SRS. We also have done an SRS, I think, earlier this year. There was one person, what are the must and mandate points that can be compromised in an SRS report? Question mark. Yes, Mauro. Well, as per standard, if you look at the details from a standard, the standard would require that 29 shall include and shall describe. But of course, that is wishful thinking. In reality, we hardly ever see an SRS where all the 29 items will be listed. On the other hand, I have to agree with what the standard is calling a good engineering practice. The more and better and detailed we describe a safety loop, the more chance in the future we have that people will not be able to make a mistake by building exactly the loop as been specified. Of course, this is subjective for most engineers because they typically think that it is not applicable for them or believe that, well, the people should know in the future what this really means, so we don't have to describe this. This is often the case. I propose to use a generic template for a SIF. And there are many different templates already available in the market. I see this often when we see projects, without giving you a name, but when I see an EPC contractor X, well, I know already the layout that the EPC contractor X will use as the layout for the safety integrity function templates, because they have been using it for the last, let's say, 10 years in the industry. Nothing wrong with that. The question is, are we really sure that this template, which they do cut, copy, paste on all the projects, is every time what we like to see when we make an assessment? And the answer is typically no. When we make assessment, we always find, let's say, particular items which are described in such a severe version that people are open to make a subjective opinion on it. And the moment you leave something subjective in safety, it can never be correct. That means that we like to do it black on white, exactly what needs to be built. The better you can describe it, the more chance in the future you will have a good working safety function. My recommendation is that the 29 items that the standard is asking as a good engineering practice, there is a reason for that. So look at this and try to fill in. If you don't find some of the particular, let's say, questions correct, or let's say, not correct was the word. If you don't find them clear enough that you cannot understand them, my recommendation would be use the book from GMI, go to chapter 8, and look on some practical examples that I may have been giving in that safety requirement specification. Yes, Mauro?
Yes, we have a question. If you can have a look to that, I may add also something.
But trying to find my Q&A, it was hidden. Oh, you have a question? Ah, it's giving in the chat box. Okay.
Yes, in the chat box.
Yeah. Well, this is strange because the webinars of GMI never have a chat box, but they forgot to disable it. It doesn't matter. I got a question from someone saying, Tino, could this normally close contact be a reset in a fire detector loop to power down the fire detectors and reset the latch detectors? I think that could be.
Tino, let me add just one thing. When a fire detector is activated because detect a fire, yeah. Okay, it is then latched. It goes into the action with the fire and gas system. Then it remains latched, and in order to restart the proper working, need to be powered down, and that's why there are these contacts with remove power to the detectors.
But this is
reactivate the functionality of the detector, which restart to detect and ready to detect the fire and to communicate.
But this is a fire and gas application which is clearly belonging into the activate, in the energize to activate story. So when he deactivates, what does he do with the reset button or the normally closed contact? They open the power to all those detectors, as this person is correctly mentioning, is actually to reset those detectors which may have been latched because they may have recognized a fire. Yes. So in that case, the normally contact becomes also an integral part of the functionality of the loop, because if that normally contact would fail, those detectors would not be maybe working correctly. Okay. All right, Mauro, thank you.
The last two questions we have now.
The life cycle of the safety requirement specification with respect to the IEC 611 and adherence post-commissioning. I'm trying to remember the question, cannot remember for the moment. I hope I remember when I see the answer. Okay, what was here the question? SRS, okay. I think it's the connection, or what is the link between the safety requirement specification towards the installation and the commissioning. And clearly the safety requirement specification, which is here shown in this box number 3 or phase number 3, is your document to explain exactly in phase activity number 4, which is called design and engineering of your safety instrumented system. That means physically in the phase number 4, you will physically design hardware in combination potentially with a logic solver or with a application logic between your in and your outs. That's what you do in your phase number 4. Once you go on site, and before you go on site, you first do your FAT, that means your factory acceptance test, which will be done with the system manufacturer who built the system. Before you ship it on site, you see here in between, we have there a stage number 2. And I have yellowed here stage number 3. That means once you go on site and you have a tested system, you will have to install commissioning. That means you have to connect all your third-party devices on your complete installation, and you have to install and commissioning loop per loop to a working, functioning loop. And they want you to make a validation. That means they want you to activate, to execute your site acceptance test. And once you have done your site acceptance test, at this moment of time, you're ready to start up your system. In other words, you're ready to introduce the hazards into your production facility. The IEC 61511 standard is now clearly dictating, mandating, requiring. You shall carry out stage 1 and stage 2 and stage 3. And especially stage 3 that I highlighted over here, before you introduce the hazards in your production unit, you shall prove with evidence that you carried out stage 3. And the difference between stage 1, 2, 3 is the following, that stage 1 and 2 and 3, all of them have in common, needs to be carried out by a senior, minimum one senior competent person not involved in your design team. And that senior competent person or that team needs to make an expert judgment to judge that the activity from phase 3 or phase 4 or phase 5 have been done correctly. So clearly, if the question was linked to the commissioning activities, well, the commissioning activities needs to be verified to have been done correctly, but at the end of the day, they need to have an expert judgment independent from the design team to make sure before you start up your installation that your system will fulfill the reference document, your safety requirement specification. And as I said here in this slide, we do have some different webinars on functional safety assessments where we may go a bit more in depth or in detail what is needed. Yes, Mauro.
Yes, we have the last question. I can read it and answer myself. Can you please arrange a similar section for selection and introduction of safety relays? Answer is yes, we already are doing that. You can have a look to the upcoming webinars and you will find this webinar available. You can have the same available on our YouTube channel. And later on, I will share also our contacts and you may have also the chance to send us an email and we can arrange, in case you are interested, also customized webinar or customized seminar in specific subject if you want and if you are interested. Now we have another, okay. Thanks for your input, very good. And very last point now, this is really the very last question. And we would like to hear from you and to have your feedback about how we did, we performed. And hopefully we gave you something to work out. And if you need anything in addition, again, you can get in touch with us or you can monitor the next webinar we are arranging. And so I will stop this and I will share. So thank you very much for sharing your time. Thank you very much for the feedback you gave us. Excellent and good. So that means we did well. Tino, you did very well. Thank you, Tino, for sharing your knowledge.
Thank you.
And well, what else? Let's go to the contact page so that in case you need, you can send us a short email. And well, what to say again? I wish you a good continuation of your day. And I wish to see you again in some of the next webinar or some of the next training, or why not some of, to see you as a customer of GMI product. In all cases, you are welcome and you can get in touch with us at this contact. Thank you again.